Today we're going to complete the notes for 2.2 conditional statements. So this is going to continue with logical arguments. If you take a look at the second line of our notes, it says, if you study, then you will survive geometry. That is a conditional statement. So we'll get into what exactly a conditional statement is right here. And we'll start by writing another example of a conditional statement. Make sure you're following along and writing down all of these statements after we go through them and following each direction, making sure to pause when necessary to make sure it's enough time to write things down. So we're going to look at our first conditional statement here, and that is, if Mr. Morelli's wife has a baby, then Mr. Morelli will not be in class on Friday. So this is a topical and relevant statement, but let's look at the parts of it and talk about the basics of a conditional statement. So for that particular conditional statement, we have two parts, an if part and a then part of the statement, and we formally refer to those as our hypothesis and conclusion. So a conditional statement is an if-then statement. In this particular statement, the if part of the statement, all the things that come after it, if, all the way up to then, that is my hypothesis. Okay, you'll notice that does not include the word if. Then when I'm looking at the conclusion, I consider everything that follows then, but does not include then. So that is my hypothesis and conclusion of an if-then statement. For statements 1, 2, and 3, go ahead and write those as if-then statements. Your answers may vary, so pause this, go ahead, try those three out, and then take a look at my solutions when you're finished. Remember, your answers will vary for these three. So as long as you have kind of the spirit of what I've said here and it is an if-then statement, then you should be pretty close to correct. So number 1, if a number is divisible by 10, then it is also divisible by 5. There's really not much leeway there. It's got to look something like that. Number 2, you should probably reverse the order here. So they give you the if part. So I want to say, if you're late to soccer practice, then you will have to run laps. The last one, probably the most variance on this one, something to the effect of, if an animal is a dolphin, then it swims in salt water, would be great. So is a conditional statement always true? The answer to that is no. So if you can come up with a counter example that shows an example of when that conjecture is false, then it's not true. Maybe it is true some of the time, but it's not always true, then we're not going to say that it is true. So let's look at some of these examples. We're going to determine if it's true or false. True meaning is it always true, not can you think of an example when it's true. And if the statement is false, then provide a counter example. And remember, false just means even if there's one instance where it's false, it is still a false statement. So take a look at those and see if you can figure out the truth value of these. And remember, if they're false, go ahead and provide a counter. Your counter examples will probably vary, but the true and false should not. So for A, that's a false statement because you could multiply an odd and an even number together and end up with an even product. The second one is also false. If you multiply two numbers together and their product is positive, then the two numbers must be positive. Well, we know that a negative times a negative is a positive. Squaring any number is larger than the original number. Well, square a number less than 0. In this case, 1/2 squared is 1/4. 1/4 is less than 1/2. You could also have just done 1 squared. 1 squared is 1, so that's not larger than 1. It's equal. D, if D is in between R and S, then RD plus DS must equal the entire segment RS. That's the angle addition or the segment addition postulate, so that is true, and it's always true. The sum of any two numbers is negative. Well, just pick any two numbers that don't add up to a negative number. That's pretty easy. If it's sunny, then it's hot outside. Well, it could be sunny outside and also 0 degrees. That would not be considered hot. So again, your examples may vary, but the ideas are all the same. So let's move on to the next page. So when we talk about logic and statements of logic, we typically use P and Q, and the arrow shows what is implied, and it shows where the if and then belongs. So when I have P with the arrow pointing to Q, what I'm saying is if P, then Q. If I flip-flop those numbers, the arrow is pointing at the P now. I would say if Q, then P. I can replace P and Q with all kinds of different statements. So for example, what we have is a converse statement, or I'm sorry, conditional statement, then the next one flip-flops what was originally my hypothesis and conclusion, and we call that a converse. So let's do the same thing here with this statement. So if you live in Illinois, we're going to make this our P, and then we'll make that second part of the statement our Q. Then you live in the United States. Well, if I'm going to do the converse of that statement, we'll just flip the Q and P. So we rewrite the converse here, and we get, if you live in the US, then you live in Illinois. And as you can see right here, that is not a true statement, because if you live in any other state in the United States except Illinois, then obviously you don't live in Illinois. So that original statement, if P then Q, just tells us, implies that if P then Q. That doesn't necessarily mean we can always go the other direction. So we're going to say that it doesn't have to be true the other way as well. Now, that's going to be a little bit different when we talk about postulates, definitions, and theorems. So a postulate is an unproven assumption that is generally accepted. Postulates are set in stone. We do not have to prove them. Essentially, a postulate is a common sense answer to a simple question. So between any 2 points, only one line can be drawn. So that was our definition of, a line is it, has infinite distance, connects 2 points, any 2 points. It's really hard to prove, but common sense kind of tells us that it's true. Then the segment addition and angle addition postulates, if a point lies between two other points on a segment, well, if you add up the two smaller segments, it's got to add up to the bigger segments. That's just kind of a common sense argument there. And the other thing we will not have to prove is a definition. So definition defines or explains what a term means. So when we defined point or array or a line or a segment, all those were definitions. Okay, definitions can be written as if-then, and definitions are always going to be reversible. So the converse will be true as well. So if we look at this definition, a right angle is an angle whose measure is 90 degrees. I can write that in if-then form as a conditional statement, and then the converse of that particular statement should also be true. And let's take a look and see if that's actually what happens. And here we go. If an angle is a right angle, then its measure is 90 degrees. If an angle measures 90 degrees, then it is a right angle. So the original conditional statement and the converse, when I go the other direction and flip-flop the hypothesis and the conclusion, that is also true. So go ahead and write an if-then statement for example 2, and write a converse as well. And remember, it should be true both ways. Okay, let's take a look. So if a point divides a segment into two congruent congruent segments, then it is the midpoint. If a point is the midpoint, then it divides a segment into two congruent segments. Obviously, you could have done my converse as your conditional statement, but the idea is the same. So you're saying if something is a midpoint, then it cuts the segment into two congruent segments and vice versa. All right, let's move on and take a look at the next page of the notes. Now, a theorem is a mathematical statement that must be proven using postulates and or already proven theorems. So our example here would be spot the dog theorem. If Spot is a Dalmatian, then Spot is a mammal. Well, let's talk about our statements. Well, 1, Spot is a Dalmatian. That would be given. We're just saying he's a Dalmatian, so that's our hypothesis. Well, that means if Spot is a Dalmatian, then Spot is a dog, because if something is a Dalmatian, then it's a dog. And then our final statement is we're saying Spot is a mammal. So if something is a dog, then it is also a mammal. So therefore, to go back up to the beginning, if Spot is a Dalmatian, then Spot is a mammal. Now, there is some reasoning in between our original hypothesis and conclusion, and that little proof that we've listed kind of shows where all those ideas came from. So is this theorem reversible? Well, let's take if Spot is a Dalmatian, then Spot is a mammal. Let's reverse it. If Spot is a mammal, then Spot is a Dalmatian. Well, no, there's a lot of mammals that are not in fact Dalmatian, so this is not reversible. And that's not always going to be true. Sometimes those theorems can be reversible. So if we look at the congruent right angles theorem here, if two angles are right angles, then they are congruent. And let's try that and see if it's reversible or not. So for number 2, this is also a case where it's not reversible. So it might sound good. If angles are congruent, then they're right angles. Well, I mean, that's true in that particular case. However, yeah, that converse doesn't really check out because there are a whole bunch of angles that aren't right angles that can be congruent. You know, 2 60-degree angles can also be congruent, but they're certainly not right angles. So theorem and postulates are not always reversible. So right now, I'd like you to do the homework for today, which would be worksheet 2. And then we'll go through those examples in class and I'll answer any questions. Just do your best on these. I know, I wasn't here for this class today, and yesterday I just kind of let you go and try and look at some of those definitions and figure some of those things out. And I appreciate your work on that, but we'll have plenty of time next week to answer questions. The idea here is to kind of maybe fumble through some of these a little bit and try these out and kind of get an idea of what you think is right or wrong, and how to do the converses and how to figure out the truth value of these things. But we'll get into this more in class on Monday. So thanks for going through these notes, and remember, worksheet 2 is your homework. Thank you.